harness time. And as we recall, there are 2 wiring harnesses on each side of the wing. There's a harness that goes all the way in the back right here, and then there's a second harness that goes over here. So what I'm going to be starting to do is the one in the rear, and that one, as I showed previously, that's going to be using the AR One Click Plus system, and that is this connector right here. And the reason for that is because we have on that connector down there, we have 2 flap servos and the lighting for the wingtip pods. And so we're going to need our 2 servo wires, so flap, and lights. So what I like to do is color code it, and so you can see what I've done here is I'm gonna wire these so that one color on both sides of the wing, one type of wire corresponds to one servo. So maybe the power box will be aileron, and then this guy will be flap, even though they're both going to be used as elevons, just to distinguish outer versus inner. And this guy is going to be the light. So here are the wiring harnesses for the rear connectors, and these will house the 2 flap servos and the navigation lights. And so you can see that I made the AR1 clicks just adapt to those, and we have this heat resistant snake skin up to a point, and then the rest of this is just I'm gonna have to figure out what the length I need to cut off. On the outside I 3D printed these holders. I kind of lost the ones that came with my AR1 Click Plus, but that's gonna be secured to the fuselage at that point. And all you can see, all the wires go in, and everything is fairly easy to replace, so we can pull these out and inspect, test, do whatever we need to. And on the inside, that is how that's going to be routed. So you can see the wires back there come down here, and this is the reason for the heat resistant or fiberglass snake skin, because obviously the turbine's going to sit in here, and so we're going to wire those, route that wiring underneath here. And then obviously that has to come up, and the reason it has to come up is you can see that the gear sits underneath this plate, so I don't want anything interfering with that. So all my wiring will have to come up through this hole and then be brought up through going to the front. Alright, holes are drilled, let's screw them in place. We're gonna use these guys, maybe the longer ones, so let's get at it. Alright, so that is the finished product. I think it looks really good. It looks very clean and professional. So obviously I have to clear looks like a huge amount of the wing, because you can see the wing profile up here and down here, to make sure that this all fits underneath it, but that's not going to be a problem. These how things are shaping up in the hot end of the turbine. I think I like how that's looking. 2 reasons why. One, obviously everything is encased and grouped together, so we have our flap harnesses here, these guys, then we have our afterburner, or rather our tail light and tail formation light harness right there, and then we have our rudder and afterburner harness in there. They're all encased in fiberglass heat resistant sleeving, so that's good. But also, to give them even more protection, I'm running these on the bottom. Heat tends to rise, so by keeping these wires down here, they should be well protected, but also well organized so that everything is easy to trace through the jet. So we're working on the front harness, and the situation here is a little bit different. So whereas in the rear we had a small opening and we could screw everything down, on the front you can see the original opening here is pretty wide. So what I had to do is put a wooden plug in there and then drill through, because this is a piece of wood that I'm gonna secure the AR plug onto. So it's pretty simple. I used CA to secure this, and I will add epoxy on the back side. What we're looking like on the back side. So once I clean the shavings off, epoxy is gonna go probably on this edge right here, and then on that edge as well. I'm gonna use the same screws here. And what I like to do is drill one, secure it. And the reason I like to do that is because once I've done that, there's less movement allowed, and so I can pivot this and then drill the second. A lot of times I've tried to drill both, and you kind of are moving around and you don't quite get the precision that you want. So now that we have that one in place, we're going to drill the second one. And secure the one click with the second screw. All right, and just like that, I believe we are done mounting the second connector. And that brings me to this section right here. So these wires here are pretty important because, as you can tell, this is really the intake of the turbine. So all the air comes through right here to get into the turbine. Let's go take a look at the front and see what that means for these wires. There's a reason why I've tied those together, cinched them here, and then cinched them together right there, and then one more as they go through the center. You can see here, from the intake of the jet, you go directly through those two holes, and so you can see that it is important to keep the wires sort of clear of that area so that your air gets a nice smooth shot. So this side is not as clean just because of the vent pipe. It's still fairly open, so the air will just go around that. But the point here is to bring up the fact that this underside really needs to be clear, because that's where the air needs to get a straight shot through to the turbine. So before we close out the wiring in the back, I remembered that we have this little situation here. So that's the wiring for the light, and there is no better way to install this. Because what I don't want is a wire hanging around the hot section of the plane. So the turbine's gonna sit somewhere around here, and this is just not acceptable to me. So what I'm gonna do is come up with a system, and the idea is I'm gonna basically get this wiring to come up front to the cold section of the plane. So we'll wire it up one lead here and one lead here. I'm gonna show you what I'm thinking. So I created this guy, and what this is basically just a brass tube that I flattened, and I'm gonna use this to make a contact point. Why brass? Two reasons. One, it's easy to mold and bend, but more importantly, it's very easy to solder. So you can see that I've soldered one wire there, and my idea is this guy is gonna sit on the side of the fuselage of the jet, just like this. Remember, it's also flat, so I can just scuff this up and epoxy this to the side of the turbine, and then I'm gonna have a screw that I'm gonna tap into the edge and basically allow it so that when the canopy closes, the screw makes contact with this guy and therefore passes electricity across. And then that'll make for a very clean setup, because all of these wires here are basically going to terminate at a screw here, and I want a screw because I want to be able to adjust the height, because the fuselage and these points are not necessarily going to be close enough. I don't know how close they are far apart, So I want to be able to get something that is adjustable. So I think a screw going through the side with threads, and I can just make that come out or go further in, so that when this canopy is definitely closed, makes contact. So regarding that beacon light, you can see what I'm going for here. So which is that we're gonna glue that electrode, whatever you want to call it. So this is the positive right there, and then conversely we're gonna glue the other one in here, and all these wiring. So here's the actual light wire, and that's just gonna get routed through the center all the way to the front of the jet, of course inside. And it's gonna be really clean, because once this is done, those wires are gonna get hidden like that. You're not gonna be able to see them, and all you're gonna see is these electrodes. Now, I should mention here that since this is brass, it'll probably oxidize over time, turn a little greenish color, we'll see, but I'm just gonna be able to clean that with some steel wool or something, and keep this connection going. So those two electrodes are in place. Turned out all I needed was CA, and those are holding pretty clean. So here's what the inside came out to be. So you can see there are two, these were M3 that I ground down, and they're stainless steel, and that's important because of a thing called galvanic corrosion and galvanic isolation. So this material here is brass. For example, you don't want to use aluminum on this, because over time the brass and aluminum will have a electrochemical reaction, and that'll eat away at the aluminum. So stainless steel and brass are galvanically compatible, which means that there shouldn't be a reaction there. So with that, I was able to get a spade terminal, get this wire or a ring terminal, and put the M3 sort of bolt through washer, then the terminal washer lock nut, and then M3 nut on both sides, and ground these down. Turns out that the tolerances in here are pretty tight. So I think now I have good contact between these two spots and these two. We'll test that. And I like this as a solution better, because then I'm gonna just put some tape to secure this guy down, and this is gonna make for a very clean turbine hatch removal. No unnecessary wires going anywhere. There we go. And we have our light, and it works beautifully. So this is a solution that I think should have been implemented to begin with. And you can see what I have there, just my stainless steel. Stainless steel M3 has been ground down. The wire's been secured in there, and that's not gonna go anywhere. And because this is just a light, I'm not overly concerned with like making sure the contact is super great, although it needs to be just good enough so that I don't get arcing. But I'm happy with that result. And so now back at the Eurofighter, and what I'm dealing with right now is the mess of wiring. And so I'm going to show how I decided to lay this out. So I basically went with putting my gear controller all up in the nose here, or further forward, and the reason is that all the connections from this guy come out the side, and so it's nice to have it be able to be flush almost up against this. The light control is going to sit under here, under the tray, and all the wires that have been plugged into it, you can see all the lights and landing lights. It is labeled, and it's just sitting in here with Velcro, but all the connections that go to it are labeled, as you can see, so you know what plugs into what, and there's a good manual online for that. The other thing that I did was, as you can see here, there's my bundle of wires that's going to go up to the smooth flight here, and as always I have labels for everything so I know what goes where. And then finally we have air brake, light controller wires, and a few other things that are going to also go up to the smooth flight in here. I've also used sort of that spiral wrap to keep my wires together, and that's because one, I just want everything together, but also because I want to provide chafing protection. So you can see there's a former here, and I don't want my wires keep rubbing and eventually wearing, so that's why I have that. My pump is going to be mounted on the side here, and it's just mounted on a plate, and that plate is secured with Velcro to the back. And then there's these two plates I made up between these two formers. So this is going to be where my fill line is going to go with that fuel dot, and then my fuel valve. And so basically there's going to be a nice route from right here to the pump, and basically just a loop just like that. So that's perfect. So the next thing is obviously going to be to bring these wires up through the tray that's going to sit up here, and I'll show you what that looks like momentarily. And as you can see, I have had holes in here with grommets, so all my servo wires are going to come through here or through here. That'll go to these channels, and then the turbine wires will come through here and get plugged into these respective channels, and then the throttle will go through here, under here, come out here, and get plugged into the smooth flight. So once this is done, I think this will be a very clean looking setup. My UAT is here. It's an Interco UAT, and it's just gonna face backwards, and all the runs should be pretty short from the main tanks to the UAT top, and then from the UAT center to the pump, which is sitting right there with the two red knobbins, and then finally the fill and drain, which is going to get routed and come out through here. So there should be pretty short runs for that setup. So I'm going to put this in and then show that final setup once it's done. So here we are after we've done some cleanup. You can see the smooth flight and all the grommets I had shown earlier. Everything is tucked and neatly put away. I had to add a receiver here, and that's basically because I figured out much later that I would need more than 16 channels to run this, and since I already had this as opposed to the big SF26, I decided to move all the non-important stuff over to the receiver. And since the receiver uses S-Bus to talk to this guy, and all of these pins can be assigned to whatever channel, it was great because now I can use some of those to power like random stuff like landing gear lights and things that are not requiring of the high resolution that comes out of the smooth flight pins. Only change there was these two ports, which is how I'm powering the TDR18. Those actually come from the smooth flight. So we take power from here and here, power the remote, the receiver, and we have a fuel dot. I have now put in the fuel line, and as you can see, that comes all the way from the UAT, snakes underneath the plate here, and then comes out to this spot, and I can take it out and stow it back down. We have put in our fuel valve there, so, and that line is coming all the way from the pump, which just sits at an angle right here. So we have a pump and comes from the UAT. These are Festo fittings, just because for convenience, so I can pull out the tray because the UAT is mounted onto this tray, and having those connectors just makes it convenient. I'll be testing those to make sure that they don't leak, and if they do, well, I might just have to replace that with continuous fuel line. It'll be a pain in the butt to service, but I've had good success with these guys, provided they're installed correctly and you use the hard fuel line like I'm using here. So I'm gonna hope that everything goes well. What's left here now is to figure out CG, because my batteries, I pulled them out of in here because batteries are gonna sit somewhere in this region. I don't know if they're gonna be for the back or all the way in the nose, so I need to figure that out, obviously. And finally, obviously run the tests for the engine and whatnot, and then attach the canopy finally. The canopy has canopy raise and lower and canopy latch, and those servos are gonna attach to these two cables. So I have one down here, and the second one. So these are the two connectors that I'm gonna use to secure the canopy raise, lower, and lock. Actually, there's one more because there's two locks. So it's almost time to get the canopy in place. And what I've done here is just connected my locking servo and my actuator. You can see the wires there. And they go to the connections that are actually going to the smooth flight and the receiver there. And so all that's left is to get this guy bolted underneath here, and then once that's done, we can get the actuator bolted onto its spot right here. So I'm gonna... Okay, quick note here. So one of the things that I really liked about this jet was that everything was electric, including the air brake, and as you can see, the canopy raise lower is also an electronic actuator. Only problem is the actuators that come with a jet are 2-wire. What I mean by that is this is what you get to control them. And when you get something like this, usually you either have limit switches inside the actuator so that when the actuator is fully extended or retracted, those limit switches will cut power. But what that also means is that you need a controller, because this polarity needs to be reversed to switch the direction of travel of the linear actuator. Now in my kit, I only got one of these things, and I'm assuming this obscure piece of electronics is probably what that is. So what I'm going to do is, I don't want this, because I don't want to have to get another controller to run this. I want to get one that A, doesn't have to go end to end with limit switches or need a complicated controller, and B, I want to be able to just plug it directly into my receiver. So I'm going to be taking this out, the one on the air brake, and replacing that with the Actuonics L1250. I'm not sure if I'll use this ratio. It might be a much slower one, but if you compare those two, they're pretty much the same. They're the same size. So again, you see that you have this 2-wire connector, which just isn't gonna work for me, and that happens to be a 30mm. You can see it's labeled in there. And I'm going to replace that with this Actuonics 30mm as well. And that way, the Actuonics stuff comes with a servo plug. So just directly plug this in to my receiver, and I'm done. Here is the new Actuonics. Here's the old one. They went together pretty quickly. All I had to do was take off the tip of the Actuonics and replace it with the tip of whatever came stock, just because of how the fitment works in here. But